Hi, I'm Andrew. Today I would like to teach you how to find the intercepts and end behaviors of functions by using a calculator. Let's take a look at the following question. It says, what are the intercepts and end behaviors of the following functions? So the first one we have here is going to be f of x, which you can remember, just think of simply as y, equals then x cubed minus 16x. All right. So the first thing is, in order to use the calculator to, and I realize this is pretty, messy. So first thing is just use the calculator, all right, and plug in the function. So go to your y equals, type in then x cubed, so x raised to the 3, hit the over button to drop the cursor back down, and then just hit minus 16x. Okay, hit graph now. So you're going to get an output that looks like this, assuming your zoom here on the calculator is in standard, all right, zoom number 6, which it probably most likely is, all right. Now, this kind of gives us a good picture, but it kind of might, it doesn't really look that great. We don't see the full extent of the graph. So maybe we're just going to adjust the window a little bit. All right, I notice most likely the graph comes up, it curves up here somewhere and then comes back down, curves down there somewhere and then goes back up, right? So what I realize is that I can see everything appropriately in my x coordinate, but the y coordinate seems to be shut out a little bit, right? It seems to be cut off. So go to your window, expand your y's, all right? Go to negative 20, y minimum, and then go to maximum 20. Let's see what happens. Hit graph. That's looking a little better, so now just make a little adjustment. Maybe go to negative 30 this time, all right? And then go to 30 for the y min and y max. So there's our graph, all right? Now let's take a look at it. So there's the output, right? And let's see if we can determine what the end behavior is like. So what do they mean by end behavior? Well, the end behavior of the graph is what happens at the extremes, all right? What happens at the extremes? What happens when x gets really large? The y value looks like it gets really large, but in a negative way, right? So we could say that, I'll write it down here. So, oops, let's move this up. So what we can say here is that as x approaches negative infinity, right, as we go out further and further to the left, the function here is going down and down and down. So the y value is also going to negative infinity, right? And then looking at the right side of the graph, right, as x is going more and more positive, as it's becoming more and more positive, as it's going to positive infinity, the y value looks like it's also going on up and up and up and up and up forever. So it looks like it's going to positive infinity. All right, so that's how you would use the calculator there, and by looking at the graph, determine the end behavior. Now, to determine the intercepts then, right, to determine the intercepts now, what we're going to need to do is look at the places where the graph crosses the axes. Which axes? X and Y. And these are the 3 points, in which they cross the axes, right? 3 points where it crosses the x-axis, and there's only going to be 1 point where it crosses the y-axis. Remember, vertical is y, horizontal is x. So what are the coordinates? Now, from the graph, we can kind of tell, right, each of these tick marks represents 1. So I had to move out negative 4 units to the left, all right? Or I had to move 4 units, to the left, and therefore that would be negative 4, right? So this intercept here, this x-intercept, so maybe what I'll do up at the top, I'll write x-intercepts. So we're going to have an x-intercept right here at at negative 4, 0. We also have another x-intercept, it looks like right at 0, right? 0, 0 at the origin. And then we're also going to have another one right over here. And that's going to be 4, 0, positive 4 this time, because we have to go out 1, 2, 3, 4 units. All right? So those are the x-intercepts. And then we realize that there's one y-intercept there, okay? So the y-intercept now is going to be at the origin as well. It's going to be 0, 0, okay? 0, 0. Now, sometimes it might not be sufficient, to look at a graph. It might be close. How do I know it's exactly negative 4 here and 0 and 4? Well, you can always go to your table function on the calculator. So hit second graph. That brings up the table. Now, what you need to do, though, is you have to have this incremented. You see how mine is incremented by 10 units? Okay. That's not going to be appropriate. I need it really incremented by 1. So you want to hit your table set button, go to second window, and start the table at 0. That's fine. And then your delta table, that just means how many, what's your increment, all right? How much do you want it to go up by? I only want it to increase by 1 unit every time, all right? The x value, that is. Now hit then second graph, and here you go, okay? So let's get this centered. Let's bring this now onto the screen. And as you can now see, really large, right? Here's going to be the value. at negative, when x is negative 4, y was 0, so that was one x-intercept. At the origin, that's another x-intercept. And oh, look, there's another x-intercept, right? So you can definitely use the table to help you out. Also recall that this was also not only the x-intercept, but also the y-intercept, all right? Basically, you might notice the pattern that whenever you have a y value of 0, those would be your corresponding x-intercepts. And then whenever you have an x value of 0, that's your corresponding y-intercept. All right? So hopefully that helps. All right, so let's now delete that. We'll get rid of all this stuff. Okay? So we took care of that first one. Now watch how quick and easy this is for the second. Ready? Let's run through this. So go to your y equals, clear out the function. Right now x cubed, so x raised to the third. Right? Hit over, then minus 27. Now go to zoom standard just to kind of get this into a perspective. Okay, now this looks a little funky, right? So it's like, wait, where's the graph? All you got to do now, just zoom out, all right? Just zoom out, hit zoom, and then go to number 3, and then hit enter. Okay, so now this gives me a little bit of a better picture, but still it looks kind of, you know, it's way too much. We got way too much x, right? We don't need it that big in the x-axis. So I'm going to shrink down that x-axis, and I realize we got something of interest going on down here on the y. So why don't we reformat now our window? All right, so x-min maybe only go out to negative 5. And then x-max go up to only 5. That's probably all we need. Y-min, yeah, go down to maybe negative 50. And I'll go up to y-max of 0. Actually, you know what? Let's do 10. So you see the axes. Let's hit graph. And there it is now, okay? So now, here is the output, okay? And I realize that the end behavior of this graph, remember, what is it going to do when it goes furthest out to the left-hand side? Well, as x is getting more and more negative, y is also getting more and more negative. So we have a similar case that when x goes to negative infinity, the y value will also go to negative infinity. And we also have a condition on up here on the right-hand side that as x goes to infinity in the positive direction, y is going to go all the way on up and up and up forever. Up and away. So as x goes to positive infinity, the y value is going to go to positive infinity as well. That would be the end behavior of this graph. Notice how they're both cubic, right? Functions, by the way, and they have a very similar nature to them. Look at their end behaviors, right? They look somewhat similar, but really not similar, the same, okay? So they're identical, the end behaviors, all right? What will be different, though, is the x and the y-intercepts. Okay, so here we have a location of a y-intercept, because that's where it's intersecting the y-axis. And right here I have an x-intercept, okay? Now there are other ways to view this. You can check out in the description below. I'll leave you some links in case you want to figure this out by using a different method, a more algebraic method. But for right now, our x-intercept looks like it's going to be equal to 1, 2, 3, all right? So the x-intercept is going to be at 3, 0. And then the y-intercept, now this would be a little hard from this graph. I'm going to have to zoom in here a little bit, right? So watch. Let's go to now, let's go to zoom, let's go to window, all right? And just go on up to now maybe negative 20. We're going to blow that area up a little bit, okay? And there it is. Now this might be a little hard, but in this particular picture now, we're dealing with negative 20, okay? And we're going to go 21, 22, 23, 24, 25, 26, and 27. Oh, interesting. So we got 27. So there's going to be a value of 0, 27. Okay. You can also use that table. So go to second table, right? Go on down. Looky here, right? Right here. When x is 3, y was 0. We said that that was an x-intercept. And that's what we wrote down over here. Let's keep going, right? Let's keep going. Oh, the y-intercept, I wrote down positive 27. I realized that should be a negative. That was a silly mistake. That's in the negative direction. So if you scroll on up, go to x is equal to 0. Sorry. Went too far. Here it is. And what's the y value right there? Negative 27. That's the y-intercept, all right? That's how you use a calculator. That's it. Guys, thanks so very much for tuning in. I hope that helps. Please help us out by liking and subscribing. I'll see you in the next video. Take care.